Okay, so this is a tutorial on how to draw the Lewis structures. And the Lewis structures have 5 main steps. I'm going to take you through 2 examples. The second example will show you 1 additional step. For the most part, they have 5 main steps. So what we're dealing with here is SCl4, which is sulfur tetrachloride. And basically the first step is to find the total number of valence electrons. And so obviously what we do is we look at the periodic table and we see that sulfur is in column 6. So we know that sulfur has 6 valence electrons. Then we look at the chlorine. The chlorine is in group 7. So we know that that has 7 valence electrons. And since there's 4 chlorines, we multiply that by 7, and total, we add them together, the sulfur and the chlorine, and we get 34 valence electrons. Step 2 is put the least electronegative atom in the center. So here we basically have the sulfur going into the center, since it is the least electronegative, and we know that from looking at our periodic table. That is, fluorine is the most electronegative, and chlorine, since it is closer to the fluorine, and the sulfur is further away, we know that sulfur needs to go in the middle because it's the least electronegative, because it is further to the left than chlorine. So you see here the sulfur in the middle and the chlorine's on the outside. And so in step 3, this is when you want to form a chemical bond between the atoms. So you can see here we have formed chemical bonds between these atoms. And these chemical bonds consist of 2 electrons. So it's 2, 4, 6, 8. So we take that number and subtract that from our valence electrons, since we have used 8 valence electrons. So we are left over with 26. Step 4 consists of completing the octets on the outside of the atoms. So here you can see that we are completing the octets for the Cl. So 1, 2, 3, 4, 5, 6, 7, 8. Same with this one, same with this one, same with this one. But we've kind of run into a problem here because 34 minus 8 equals 26. So completing the octet uses 24, and we are left over with 2. So what is the 2, and what do we do with that extra 2 valence electrons? Well, sulfur, as you can see on the periodic table, is here. And some of these elements, or actually most of these elements, break the octet rule. The only ones that, and this is how I memorize it, that follow the octet rule are carbon, nitrogen, oxygen, and fluorine. Most of these other ones break the octet rule, and I usually like to think that they can hold more from this point down, just in general. So we know that S breaks the octet rule. And so in step 5, the central atom does not have a full octet, move electrons. Well, we don't really need to move any electrons here since we have 2 extra electrons. And so what do we do with those 2 extra electrons? Well, since sulfur can break the octet rule, because see, it has 2, 4, 6, 8, and it has a full outer shell. But since it can break the octet rule, it takes on 2 more. So sulfur actually has a total of 2, 4, 6, 8, 10. And that is where an extra additional electron goes. Okay, now time for example number 2. Okay, so this is example 2. Okay, so I did this example just because it has 1 additional step from the main 5 steps, and we're just going to go through this one just to help show you that additional step if you run into one of these problems where there is an ion. So we're dealing with CO3 2 negative with a 2 negative charge. So this is a carbonate ion. And so step 1 here, we just follow it like last time. We find the total number of valence electrons. So here we have total number of valence electrons. We look again at the periodic table, and we have, since carbon is in the 4th column, we have 4 valence electrons. And then we look at the O. O is in the 6th column, so we know that that has 6 valence electrons. And since there's 3 O's, we have to multiply that by 3. Now here, when we have a charge, we know that at 2 minus, it's gaining 2 valence electrons, so we add that 2. So total, we have 24 valence electrons. Now in step 2, we put the least electronegative atom in the center. And so again, looking at our periodic table, we look at O versus C. Well, we know that when electronegativity moves to the right, up and to the right, it's more electronegative. And we know that fluorine is the most electronegative. So coming back from that is the next one is oxygen. Well, we know that carbon's further away from oxygen, and that oxygen is more electronegative. So then we put the carbon in the middle since it is the least electronegative, and you can see the oxygen surrounding it. So we move on to step 3, and in step 3 we form a chemical bond between the atoms. So you can see here the carbon, we're forming chemical bonds with the oxygens. So that consists of 2, 4, 6 valence electrons, which you can see here, 24 minus the 6, we are left with 18 valence electrons. That is when we move to step 4. Complete the octets on the outside of the atoms. And so you can see here, we're basically just putting these remaining 18 valence electrons around the outside. As you can see here, 2, 4, 6, 2, 4, 6, 2, 4, 6, and with the bonds in the middle, that completes the 8. So now what about that carbon? We're not left with any additional valence electrons to complete its octet. And from the previous slide, we know that a carbon atom always follows the octet rule, so we have to complete that octet. So we go to step 5. The center atom does not have full octet. Move electrons from outer atoms to form double bonds or triple bonds. Well, since we don't have any left, we need to obviously pull some and share some electrons from one of these oxygens. So which ones do we do it from? We will move these 2 down, and so when you move those 2, it forms a double bond between this carbon and this oxygen. And when that happens, this oxygen is now surrounded by 4 and has a double bond with carbon. So now carbon has, just shown here, 2, 4, 6, 8. So now we have completed the octet for carbon. Now this oxygen still has 1, 2, 3, 4, 5, 6, 7, 8. So all the octets are full. However, we have a charge with it. So that leads us to step 6. And in step 6, we have to calculate the formal charge for the ions. And basically doing this, all we do is look at the carbon, which has a formal charge. We know it has 4 valence electrons. And the bonded or the unbonded electrons, we know that it has a total of 4 as well. We know this just looking at our structure here, and that we look and see that the carbon here has 1, 2, 3, 4. So that is the bonded or the unbonded. Here they are bonded. 4 minus 4 equals 0. So this does not have any charge. And we look at our O's. We have 3 different O's. They could all be different, especially because this one is double bonded. Let's take a look at the double bond first. So this double bond, we can see it has 1, 2, 3, 4, 5, 6. Well, we know that it initially has 6 valence electrons, so that's 6 minus the 6, 4 unbonded and 2 bonded is equal to 0. So then we move on to our second oxygen. That second oxygen has 1, 2, 3, 4, 5, 6, 7. Well, that runs into a problem because our 6 minus our 7 gives us a -1. Well, it's a -1 charge. And then we look at our other one. Well, that's exactly the same as this oxygen, made up with a -1 charge. And as we can see, we're shooting for ending up with a -2 charge. So this -1 plus this -1 gives us a -2 charge. And how this is written is, here's your structure with brackets around it showing your -2 charge. Thank you.